Okay. Um, Good day, students. How are you doing? My name is Mr. Timothy Olawale, and I'll be taking you mathematics this morning. I will be teaching you trigonometry. Okay, trigonometry. And what is trigonometry? Trigonometry is a branch of mathematics. All right, pay attention. That focuses on relationships between the sides and angles of triangles. You see that? Trigonometry is a branch of mathematics that focuses on relationships between the sides and angles of triangles. And so the word trigonometry comes from the Latin derived of Greek words for triangle, triangle, and measure, metron. Okay, so that's why we have trigonometry. All right, the relationships between the sides and angles of triangles. Okay, so the trigonometry is quite a broad topic. Okay, but we are going to focus in this class, and one or two more classes to come. We're going to focus on right angled triangles. Say after me, say right angled triangles. Okay, right angled triangles. And so this is an example of right angled triangle. Okay, we have different types of triangles. We have the isosceles triangle, we have the equilateral triangle, we have the scaling triangle. Okay, an isosceles triangle has two sides equal. Okay, and an equilateral triangle has the three sides equal. Then a right angle triangle contains an angle 90. This box here is angle 90. This is an angle 90. And so this is a right angle triangle. Are you with me? Okay. And you can see that this triangle, of course, has three sides. This longest side, okay, is called the hypotenuse of the right angle triangle. It's called the hypotenuse. All right, it's slant and is the longest. All right, the triangle can be drawn in any way. We can draw the triangle like this. Okay, we can draw the triangle like this. Okay, we can draw the triangle like this. Okay, in any way we draw it, the slant side is still the hypotenuse. Okay, did you get what I'm saying? Now I want you to pay attention to this. That the other two sides, okay, is either opposite or adjacent. So there are three names, all right, for the sides of a right angle triangle. We have the hypotenuse, we have the opposite, we have the adjacent. All right, and I've described that this land side is called the hypotenuse. Okay, now how do I know the one that is opposite and the one that is adjacent? It is relative. All right, it is relative. Now look at this. Supposing I have an angle here, let's call this angle theta. You see this? Let's call it angle theta. All right, the side that is facing it is called the opposite. Why this last side is called the adjacent? So the side facing the angle is opposite, while the third side will be the adjacent. Did you get that? Did you get that? All right. So that means that let's take this particular right angle triangle now. Okay. Let's assume that this is where the angle we are focusing on is. Okay. Let's call it angle X. Okay. Let's call this angle X. Now this land side is called what? The hypotenuse. Okay, and this side is called what? The opposite. And this This place is called what? The adjacent. So the opposite is not fixed. It depends on the angle we are focusing on. Is that clear? Is that clear? So let's look at it again. We have three sides in a right angle triangle. We have the hypotenuse, we have the opposite, and we have the what? Adjacent. Okay. So, and I'm sure you are familiar with that before. Okay. Now, I want us to look at what we call trigonometric ratios. We call it trigonometric ratios. Now look at this. Let me focus it properly. Trigonometric ratios. Now we have three fundamental trigonometric ratios. Then I'm going to teach you another three. Okay, I'm going to teach you another three. Let's take this right angle triangle. This right angle triangle. Look at this A. Look at this B, and look at this C. Are you with me? Okay. Now, and let's say we have an angle theta. Okay. Let's say we have an angle theta. All right. Now, this is the opposite, right? This is the adjacent, right? And this is the hypotenuse. Okay. Now, the first trigonometric ratio is sine theta. Sine theta. Sine is opposite over hypotenuse. Sorry. Sine theta is opposite over hypotenuse. So we say opposite over hypotenuse. Did you get that? Sometimes you write it as up over I. Something like this to make it easier. Are you getting me? Okay. So, are you with me? All right. So, then we have cos theta. We have cos theta. Now, cos theta is adjacent over hypotenuse. That's adjacent over hypotenuse. Then we have tan theta is opposite over adjacent. That will be up over adjacent. So usually in mathematics we call it SOHCAHTOA. SOHCAHTOA. Let me quickly bring it out. SOHCAHTOA. Something like this. So it means, are you with me? Sine is opposite over hypotenuse. Just look at my pen. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Is that clear? Is that clear? Okay, so that is what we call SOHCAHTOA. But you see, that's not all for today. That's not all. That's not all to be learned for now. All right. We have what we call sec theta, secant theta, sec theta, sec theta. Okay. Sec theta is 1 over cos theta. 1 over cos theta. We call it sec theta or cos or secant theta. It's actually secant theta. Look at something like this. Secant. But we in short form we call it sec theta. Then we have, are you with me? We have cosec theta is 1 over sine theta. And then we have cot theta is 1 over tan theta. So did you see that? Sec theta equals to 1 over cos theta. Cosec theta equals to 1 over sine theta. Cot theta equals to 1 over tan theta. Is that clear? So that means we have 6, we have 6 trigonometric ratios. We have 6 trigonometric ratios. We have sine theta, we have cos theta, we have tan theta, we have sec theta, we have cosec theta, we have cot theta. Is that clear? Beautiful. So let's move on. Now there is something I must teach you. I must teach you before we move on. All right. Apart from the trigonometric ratios that we need to learn to, it's called the Pythagoras theorem. Let me bring that closer to you. is called the Pythagoras theorem. It's called the Pythagoras theorem. Pythagoras theorem, you know. And as I used to joke, Pythagoras is my friend. He used to be my good friend. All right, so let's move on. The Pythagoras theorem. That theorem focuses on the sides of a right angle triangle. So look at this. I want us to label it. Look at this. Let's call this A. Let's call this B. Let's call this C. If this is A, the side here will be called side A. If this is B, this is called side B. If this is C, this is called side C. This is the hypotenuse, and either of these can be the opposite or the adjacent as, are you get what I'm trying to say? Depending on the angle we are focusing on. I think we've done that previously. Is that clear? Beautiful. So, now what does the Pythagoras theorem state? The Pythagoras theorem states that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. You see that? It's clear. The Pythagoras theorem states that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Simple. Simple. I want you to understand this because, you know, the next class we're going to take a few examples. So in a case like this, okay, I think I should even take some examples now. In a case like this, we have, what's the hypotenuse? B squared equals to A squared plus what? C squared. This is the hypotenuse theorem. So there are times that we're going to need this hypotenuse theorem to get one side or another side. Okay, and we'll need them when we are, you know, solving questions involving, you know, the Pythagoras theorem. Is that clear? Is that clear? Okay, so let's take a very simple example today, and then we call it a day for now. Okay, now let's take an example. Given the triangle below, example, given the triangle below, find A sine theta, B cos theta, C tan theta, D sec theta, E cosec theta, and F cot theta. Did you see that? Okay, so where is the triangle? This is the triangle. Okay, now this is 3 and this is 4. Okay, so you see that. So we have this as 4, this as 3, and we don't know the side. Okay, so this question now says find sine theta, find cos theta, and find tan theta, and find, you know, we are looking for the 6 trigonometric ratios now. So shall we? All right, good. All right, so now let's solve. Solution. Solution. Let's bring out, you discover that for us to find sine theta, okay, for us to find sine theta, we will need the hypotenuse. Why? Let's go back. We discover that sine theta is opposite of hypotenuse. So we only have the opposite. We don't have hypotenuse. So we need to use Pythagoras theorem. So you see that they work hand in hand. Are you get what I'm trying to say? So look at this. Let's call this hypotenuse x. All right. So let's just using Pythagoras theorem. Using Pythagoras theorem. Are you with me? We have x squared. You know this, you know, hypotenuse square. Let's come back here. Equals to opposite square, right? Plus adjacent square. So x squared equals to 4 squared plus 3 squared. X squared equals to 9 plus 16. All right. X squared equals to 25. And you know there is a square here, so when the square moves, it becomes square root. So x equals to the square root of 25. Okay, x equals to 5. You get that? Did you get that? X equals to 5. So that means our hypotenuse is 5. So from there we can get anything that we're asked. Okay? Can we continue? Beautiful. Okay, so let's now go straight. So therefore A equals to sine theta. What's sine theta? Opposite over hypotenuse. So, and so what's our opposite? 3. What's our hypotenuse? 5. That's all. B cos theta adjacent over hypotenuse. That will be 4 over what? 5. See? Are you getting me? Am I too fast? All right, so look at that. Tan theta equals to opposite over what? Adjacent. 2. Opposite over adjacent. That will be 3 over 4. You see that? Opposite over adjacent. 3 over 4. So let's look at D. D. Can you get that? Like that, all right. D. What's the next question? Sec theta. Sec theta is what? 1 over cos theta. And what is 1 over cos theta? That'll be 1 over 4 over 5. And that's a reciprocal. You simply turn it upside down. 5 over 4. All right. So let's look at E. Are you with me? Cosec theta equals to 1 over sine theta. That'll be 1 over, what's our sine theta? 3 over 5. That'll be 5 over 3. Okay. And then F, okay, is cot theta. That'll be 1 over tan theta. What's tan theta? 3 over 4. 1 over 3 over 4. Stay with me. That'll be 4 over 3. That's all. That's all. Did you get that? Did you understand that? So let me make it a bit clearer here now. All right. Is it clear? Okay. Okay. So that's that for that. So that's where I'm going to stop for today. All right. You can listen again and you can watch again to understand it better. Let me give you a class work. A class work that you can just play around with to be sure you get it. So let's do something around this. All right. Let me give you this. Look at this. Okay. 1 root 5 theta. Okay. So we say find. Okay. Find the 6 trigonometric ratios, all right, of the triangle, of this triangle. Okay, so I want you to try that. Quite simple, and get back to me. All right, thank you very much for listening. Thank you.